imagine searching the cosmos for signs of life, when suddenly a signal appears, so powerful and precise, it demands immediate attention. On August 15, 1977, astronomer Jerry Eman, working with Ohio State University's Big Ear radio telescope, discovered just that. Lasting only 72 seconds, the WOW signal was a burst of radio energy at a frequency near hydrogen, the most abundant element in the universe. What made it truly unique was its intensity and narrow bandwidth, unlike any known natural or human-made source. Eamon's astonishment was so great, he circled the print out and wrote a single word: "Wow." Since that moment, astronomers have scoured the sky, searching for a repeat, but the signal has never returned. Was it a broadcast from an alien civilization or a rare cosmic event? The WOW signal remains a singular event, a cosmic whisper that challenges our understanding. But to even hear this whisper, we first had to learn how to listen. That story begins decades earlier, with a man who was just trying to fix static on a telephone line. That man was Carl Jansky. In 1932, the young Bell telephone engineer is tasked with a simple problem: find the source of static disrupting transatlantic radio calls. To investigate, Jansky constructed a massive, bizarre rotating antenna, dubbed Jansky's merry-go-round. Over several months, he carefully recorded the static's behavior. He noticed a repeating pattern, but it wasn't peaking every 24 hours. It peaked every 23 hours and 56 minutes. This subtle but crucial difference meant the signal wasn't coming from the sun or any earthly source. It was matching the sidereal day, the time it takes for the stars to return to the same position. Jansky had traced the radio waves to the center of the Milky Way galaxy. He was the first human in history to detect a radio signal from outer space. His accidental discovery laid the foundation for radio astronomy, opening an entirely new window to the universe. And soon that window would reveal something. The next great mystery landed in 1967. A graduate student named Jocelyn Bell Burnell noticed a signal in her data that pulsed with such precise mechanical regularity it seemed artificial. Every 1.33 seconds, like clockwork, this cosmic beacon would flash. The signal was so regular that Bell and her thesis advisor, Anthony Hewish, were baffled. They half-jokingly, half-nervously labeled their discovery LGM-1 for Little Green Men 1. The truth, as it turned out, was even more extraordinary. These signals weren't from alien civilizations, but from pulsars, rapidly rotating neutron stars. These are the incredibly dense, city-sized remnants of massive stars that have exploded as supernovae. Spinning hundreds of times per second, they shoot beams of radiation from their poles, like cosmic lighthouses. The discovery was so significant, it led to the Nobel Prize in Physics in 1974. Radio astronomy wasn't just finding static anymore, it was finding the universe's most exotic objects. But the story of radio astronomy was just getting started. Later in 1974, astronomers Joseph Taylor and Russell Hulse discovered something unprecedented: a binary pulsar system. Two pulsars locked in a deadly orbital dance around each other. They began to time their pulses, and they realized the two dead stars were spiraling closer together. They were losing energy. But where was the energy going? Their observations proved, with breathtaking precision, that the energy was being lost as gravitational waves, ripples in the fabric of space-time itself. It was the first indirect proof of Einstein's greatest prediction, a discovery so important it earned them the Nobel Prize in Physics in '93. Radio telescopes had solved a cosmic homicide, proving that even gravity's ghost could be heard. As our technology advanced, so did our ability to peer deeper. We found quasars, the cosmic microwave background, and soon a new mystery that continues to baffle us today. That new mystery is the fast radio burst, or FRB. These are incredibly bright, millisecond-long bursts of radio waves that flash from distant galaxies. They unleash more energy in 1,000th of a sec than our sun does in an entire day. Some theorize they are the death throes of strange exotic stars. Others propose more exotic possibilities. We simply don't know. The mystery endures, driving us to look deeper, listen more carefully, and build more powerful instruments. We needed to build the biggest ear on Earth, Enter the Square Kilometer Array, or SKA. This is humanity's most ambitious attempt yet to listen to the cosmos. Currently under construction across 2 continents, Australia and South Africa, this massive network of radio telescopes will combine to create an effective collecting area of 1 square kilometer. When completed, it will be the world's largest and most sensitive radio telescope, capable of detecting signals so faint they could be drowned out by a typical cell phone on the moon. The SKA represents humanity's greatest leap forward. Its unprecedented sensitivity will allow scientists to peer back to the cosmic dawn, the era when the first stars and galaxies formed after the Big Bang. It might help us understand the nature of dark energy, the mysterious force driving the universe's expansion. And perhaps most tantalizingly, it could finally help answer that question that has haunted us since 1977. Are we alone? The implications of the SKA's potential discoveries are staggering. It could detect radio signals from alien civilizations, if they exist, up to 50 light-years away. It might unveil the processes that led to the formation of the first galaxies, helping us understand our cosmic origins. But beyond these specific objectives lies a deeper truth about human nature. From Jansky's rotating antenna to the SKA's vast network of dishes, our drive to understand the universe reflects something fundamental about our species. We are explorers, driven by an insatiable curiosity about our place in the cosmos. Every day, radio telescopes around the world continue their patient vigil, listening for new signals, ready to capture the next wow moment that might change our understanding of the universe forever. Perhaps somewhere out there, another civilization is looking up at their night sky, wondering the same things we do. Maybe they're sending signals into space, just hoping someone is listening. Thanks to the remarkable science of radio astronomy, if they are, we're getting better at listening every day. The hunt for the universe's most mysterious signals continues, and with each passing year, our ears grow sharper, our understanding deeper. As we conclude this journey, remember that every time you hear static on your radio, you're hearing more than just noise. You're hearing echoes of cosmic events, whispers from distant stars, and perhaps, just perhaps, messages we haven't yet learned to understand. The next great discovery could come at any moment, and when it does, it will join the ranks of the wow signal, pulsars, and all the other mysterious cosmic messages that have shaped our understanding of the universe and our place within it.